Omar came to the factory and did a dry cycle run with us after we finished the press. And he was there for about 3 days, and we were seeing what the limits of the machine were, as well as Omar. And we definitely found Omar's limitation. We almost found the machine's limitation, and a few parts later we slowed everything down to match Omar. But at this point, yeah, I think Omar's going to do it. I really do, and I think he's going to do it in a big way. Let's go. What we do here is very much like what the automotive industry does. When they go into the racing with Formula One, NASCAR, etc., they're taking the machinery to the maximum. And that technology trickles down to the machinery that you run currently on the streets as you drive your cars today. With manufacturing equipment, it needs to do the same. We need to drive it to the extreme so that we can understand what the product is capable of, the longevity of it, and when it's going to fail. The success with something like this is not a guarantee. You actually are really pushing the limits, and you take it to the point where components are going to fail. And then at that rate, you can tell what to change and how to blend that into your equipment that you currently build. As you do that, you become a better manufacturer and you make a better product for the consumer. I think this time we are pushing the limits of the human factor. Loading this machine at these speeds is next to impossible. I mean, it looks easier than you think it is until you step up to the pallet. Once you stand there and you try to get a shirt on at those speeds consistently, it's frightening. I consider myself a loader. I stand in front of the machine. I get one shirt on and decide I'm not going for the second. It's that quick. We've did this 3 times now, and every time we get back with our engineering staff, and during the engineering meetings, we talk about the temperatures the gearboxes see, the motors, the amperage that are driven, the servos, the longevity of them. And we also send some components back to our manufacturers, vendors, and they check the components for durability and longevity to see how we shorten the lifespan of an electronic component. And once they figure that out, it allows them to make a better product so that we can make a better product in turn. Well, the indexer is extremely fast, so getting the pallet from point A to point B, the operator has more time to load. So actually his speed to get the garment on, it doesn't have to be as fast as it was the previous time because the pallet's there longer. The shear factor on the ink, when we're running the ink, we're running plastisol at this run, and the plastisol will actually break down its viscosity and look like water ink in the streams at speed. because the shear factor and the heat starts to break down the inks even at this speed. Working with Wilflex Ink, they're one of the leaders in the industry, and we recognize that. And we've partnered with them to do the best job we can and get the highest speed with the best coverage. Wilflex seems to handle that quite well. We watch the inks, the shear factor, the cure factor, and the clariness of the print at the end of the run, and they're one of the best. We're also using a Gildan product. The Gildan product is very consistent. Not a lot of length, not a lot of loose strings. Print quality is excellent on the substrate. So we're very happy to have the partners we have in this. We could not do it without either one of those companies. They all count now, big time. Now you're printing everything to miss, every mishap for under 2,000. Go. Go for it. Come on, you can do it, man. This is for the money. You gotta go now. Go for it. Seconds. Come on. Go. 15 seconds. 3, 2, 1, stop. Congratulations, brother. You did it. Wow. $2155. 2155. Congratulations, buddy. That was fantastic. Really was.